Why can we send machines into space but lose them at the deepest place on Earth? Why can our technology survive the cold, the heat, and the emptiness of space but fail almost instantly deep under the ocean? What is down there that breaks our strongest machines so easily? That's the question we're answering. The place where our technology starts to fail has a name: the Mariana Trench. It sits far below the surface of the Pacific Ocean, about 11 kilometers down. That's deeper than any place humans can reach on their own. As machines travel lower and lower, the ocean above them begins to stack up. More water, more weight, more force pressing in from every direction. Down there, nothing is balanced. Everything is being pushed on, all the time. This is where technology stops feeling reliable. Cameras that work perfectly at the surface begin to flicker. Screens that should stay on suddenly go dark. Signals that should come back never do. The Mariana Trench isn't unexplored because we don't try to reach it. It's unexplored because nothing stays working there for very long. There is one reason our technology fails down there. Not darkness, not distance, not bad luck. Pressure. Pressure is not loud. It doesn't attack. It doesn't rush in, it waits. As machines sink deeper, the ocean presses in from all sides. Not just from above, from the left, from the right, from below. It never stops. There is no moment of relief. No pause. No break. Imagine this. You lower an empty plastic bottle into the ocean. At about 12 meters, the bottle starts to shrink. It doesn't snap. It simply begins to collapse. At around 18 meters, the bottle is clearly deformed. The shape you recognize is already fading. By the time it reaches about 23 meters, the bottle is almost completely crushed, barely resembling what it once was. And that's still shallow water. Now imagine going down nearly 11,000 meters to the bottom of the Mariana Trench. Down there, the pressure isn't just stronger. It's more than 1,000 times greater than what you feel at the surface. At that depth, pressure doesn't bend things, it doesn't give warnings, it simply overwhelms. Anything lowered into that environment is pressed from every direction, without pause and without mercy, and given enough time. It can crush or completely destroy almost anything that enters the place it controls. It doesn't matter how strong something looks. It doesn't matter how expensive it is. It doesn't matter how carefully it was built. Pressure doesn't test strength, it tests patience. Hour after hour, it pushes on every surface, every edge, every corner, every tiny gap. And the dangerous part is this: pressure gives no warning. There is no shaking, no noise, no sign that something is about to go wrong. Things look fine right up until they aren't. A tiny weak spot begins to form, so small you could never see it. And pressure notices. It doesn't need a big opening, it only needs time. That's why the Mariana Trench is so hard to survive. Not because it is violent, but because it is constant. And nothing we build is designed to be pushed on forever. Most people imagine failure down there as something dramatic. A loud break, and a sudden crash, a violent end. That's not how it happens. In the Mariana Trench, things usually fail without making a sound. A screen freezes. A number stops changing. A signal takes a little longer to come back. Nothing looks wrong at first. The machine is still there. The lights are still on. Everything seems normal, but something small has already shifted. A door that once sealed perfectly no longer fits quite the same. A tiny gap forms, too small to see, too small to notice. And the ocean finds it. Not right away. Not all at once. Drop by drop, the pressure pushes in. There's no alarm for this, no warning message, no last-second fix. From the outside, the machine looks calm. From the inside, it is losing a battle it cannot win. When the end comes, it doesn't announce itself. There is no final scream of metal, no explosion. One moment, the signal is there. The next moment, it isn't. And that's usually the end of the story. There is often nothing to recover. No clear remains, no clue of exactly what went wrong. Just a quiet failure at the deepest place on Earth. The most dangerous breakdowns are never the loud ones. They're the ones that happen before anyone realizes there's a problem. At this point, a lot of people think the answer is simple. Just build it stronger. Thicker walls, more metal, bigger parts. If pressure is the problem, then strength should be the solution. But down there, strength becomes a weakness. The heavier a machine is, the more it has to support. More metal means more joints. More joints mean more seams. More seams mean more places where things can go wrong. Every bolt is a risk, every edge is a weak spot. Even if most of the machine holds, it only takes one small failure. One seal that isn't perfect, one spot that bends just a little too much, and pressure waits for exactly that. Making something stronger also makes it less forgiving. There's no flexibility, no room to adjust. When something finally gives, it doesn't bend slowly, it fails completely. That's why building thicker and heavier has never solved the problem. Down in the Mariana Trench, survival isn't about strength. It's about enduring pressure that never stops pushing. And so far, nothing we build can do that for very long. So what about robots? If humans can't survive down there, why not send machines instead? Robots don't need air. They don't feel fear. They don't panic. That sounds like the perfect solution, but robots still live in the same environment. Well, they still feel the cold. They still feel the pressure. They still have moving parts that can fail. Down there, the water is near freezing. Batteries drain faster, motors slow down. Small parts stop moving the way they should. And then there's the problem of distance. The deeper a robot goes, the harder it is to talk to it. Signals take longer to travel. Some don't come back at all. That means the robot has to make decisions on its own. And when something goes wrong, there's no one there to fix it. No hand to tighten a loose part. No second chance. Most deep-sea robots are built knowing they might never return. They are sent down once, they do what they can, and if they fail, they stay there. Robots don't solve the problem of the Mariana Trench. They simply last a little longer before the ocean wins. Because in the end, machines still have limits, and the trench is designed to find them. This isn't just a story about one place in the ocean. It's a reminder that there are parts of this planet where we don't belong. Not because we're not smart enough, not because we're not brave enough, but because nature sets the rules. The Mariana Trench doesn't care how advanced our technology becomes. It doesn't care how much money we spend or how carefully we plan. It simply exists the way it always has. This isn't a failure of exploration, it's a boundary, a line that shows us how far our tools can really go. And maybe that's the point, because understanding our limits is just as important as pushing past them. The deepest place on Earth isn't waiting to be conquered. It's reminding us that some places remain untouched for a reason. And yet, we keep going back. Not because it's easy, not because it's safe, but because sometimes the trench lets us see something unexpected. Sometimes a camera catches movement where nothing should be alive. Sometimes a signal returns with data no one was looking for. Some of the most important discoveries in the Mariana Trench were never planned. They were accidents. Moments where technology failed, but not completely. Moments where we caught a glimpse of life that shouldn't exist. Life without sunlight. Life under crushing weight. Life that rewrites what we thought was possible. We don't fully understand it yet. And maybe we're not meant to, because every time we look deeper, The trench reminds us how little we truly know, and sometimes it allows us to see things that we were never supposed to find.